Hi everyone, in this video I will continue to make demonstrations for QGIS training manual with multiple modules for the QGIS beginner. Actually, this video will be focused on module 7 of the QGIS training manual, Rasters, with some lessons regarding working with raster data, changing raster symbology, and terrain analysis. So as usual, after opening this QGIS desktop with new map canvas, you need to save this map as project with this icon, Save As. In this case, I just created this rep3 folder, and then I will use this name of project as a rep3 Rasters. Okay. Then just click Save. So I will bring some data, raster data with this one. This Open Data Source Manager, just click. And then you need to click this raster tab. After that, this browser button. And then you need to find this folder for QGIS training data master folder. In here, exercise data, and then just find this raster data, and then you can find these 4 rasters. So with the shift button, you can select all these 4 TIF file. So just click open, and then add to on this map canvas. Okay. So after that, I will create a virtual raster data with some processing. So you need to click this processing tab to select this toolbox. And then on this processing toolbox window, you can find this GDAL and expand this raster miscellaneous toolbox. And then you can find this build virtual raster tool. Double click, then you can open this new window. On here you need to select input layers, so click this input layers. After that, you can select these 4 already loaded data, so select all button and just click OK. So we just selected these 4 different elements, and then you need to uncheck this one. Place each info file into a separate band. If you need this one, check, but in this case, just uncheck. And then you can find the other parameters, but just leave as a default. So just click Run. So after some seconds, you can get this virtual raster data. So close this window, and then you can find this virtual data. So how about uncheck all these already loaded data, the raster data. So we have this virtual raster data. Okay. So again, you will open, double click with this build virtual raster tool. And if you want to save this raster data on your folder, you can select on here with the name of the virtual file. Okay, so just close. So again, on here we just created this virtual raster data with the merged and reprojected one. So if you check this properties, layer properties with source tab, you can find this data, virtual data, temporary data, just uses some default coordinate system with this default map. Okay, so it already have projection, but this would be just temporal data. So if you need to save, so if you need to use this virtual data with a file based layer, so you need to reproject and merge this data based on this virtual, but in that case you need to save that layers on your folder. So for that you need to use some tools using this GDAL toolbox On here, you can find the raster projections. On that, you can find this warp project tool. So on here, already selected this virtual data, and then you can find this target CRS. So you need to click your wanted the CRS. In this case, just WGS 84. And then if you need to save this file, you can use this browse button with the reprojected one. But I will not save this layer on here, but I will just click the virtual based projected the last one. So just click run. So after some seconds, you can find this reprojected temporary layer, raster layer. Okay, so click close. And then I will also find another tool to merge these four different data. So actually we will use this virtual data. It already created as a merged, but I will use and try to use this merge tool. So on this raster miscellaneous toolbox, you can find this the merge tool on here. So just input layer, you can just use this virtual things. It already merged, but I will select this one. If we want to, these four different rasters, you can do, but I will just click this virtual raster data in this case. Again, if you want to save this merged raster data, you can use on this button to save your file. So in this case, I will just run with this one. So click run. Again, some minutes are required to complete this merge tool. So after that, you can find this merged the temporal layer, raster layer. Okay, just click close. So you can find this merged one and the projected one and virtual data from these four different raster data. So again, if you want to save these the raster data, you can do during the processing with the tool, these tools. Okay. So with that, if you want to save the project, you can use this button, but I will not save this all the created this the temporary file, so I will remove from this project memory layer. Okay, so I will not use all these already processed data. So remove layer you can use. So now I will demonstrate how to change Raster symbology. So firstly, you need to open data with this data source manager with the Raster tab. I will open another Raster data on this SRTM folder, this TIF file. So double click and click to add on this Mac canvas. So after that, how about right click to zoom to layer? So yeah, it already zoomed to layer. After that, right click to see this property. Click and then you can find this Symbology tab on here. So for this raster data, you can change the symbology using this layer property with this Symbology tab. So firstly, you can find this render type already selected with single band gray. And also you can easily find the color gradient black to white. So you can also change this one. Yeah. So I will make as a default with black to white. So also you can adjust the minimum and maximum cell values with this one, and then if you expand this min max value settings, you can also change with these options. Okay, I will not cover all these the different options, but you can easily understand with this one. And also you can find many the other the options on here. So in this case, I will just change from this single band gray to single band pseudo color. So click this one, and then you can find this the default color ramp. On here you can find this red to blue. So if you want to blue to red, so you can use invert color ramp. I would like to select this one, and then most required would be press this classify button. Okay, so this is just default one to demonstrate to you how to change this symbology on with the simple example. Also you can select all these different options on here. So after that I will just apply this one. So click OK. So you can find this the different colors for this the DM data, but you can find some the outlines with the zero data, no value data. Okay, so in this case, again to right click to open property, and then you can use this transparency tab. In here you can easily find the transparent pixel list with this custom transparency options. So in this case I just use this one, add values from the display. So how about click this one. After that I will make transparency with this the zero values. So click this one. So you can find this from 0 to 0 will be 100% transparent. Okay, so just click apply. Then you can find this the 0 value is just we just make transparency. Okay, transparent. Okay, so again property box, you can also make your own values with this value, with these icons. So I will not do that. So this would be very simple demonstrations for how to change the symbology. So these are some of the basic functions to get you started with Raster symbology. QGIS also gives you many other options such as symbolizing a layer using paletted and unique values, representing different bands with different colors in a multispectral image, or making an automatic hillshade effects. So based on this SLTM DEM data, I will make some demonstrations for terrain analysis. Firstly, I will calculate a hillshade with the processing tools. So on this processing tab, click this toolbox and then open this raster terrain analysis. And then you can find this hillshade tool on here, double click. So I just selected this one, the SLTM as an elevation layer, and then you can use this G factor, and also you need to select this azimuth horizontal angle as well as this vertical angle. So leave as a default. So you can see in here what means all these parameters. Okay, so after that, in this case I will save this hillshade data as a file. So click this one, saved file. So I will save in my rep3 folder with this one as a hillshade. So name the hillshade and just save. After that, you need to click to run this button, and then you can find this hillshade raster. Okay. So with this hillshade, I will make some things on here. So please click this SLTM properties. I will change some color ramp with this Viridius one. Then just apply and click OK. And also on here, again, the properties, we just clicked the previous job, just minus, and then apply OK. So on here, click the hillshade, and then also I will make some transparency with this hillshade button. So in this case, just 50% for that. Just click apply, and then you can see this hillshade with the DM data. This is more clearly see the terrain data on this. At this point, how about save this project with this save project button? And then I will make another terrain analysis with this processing toolbox with this raster terrain analysis. In this case, I will make some processing with this slope. So double click, and then just use this DM data first, and then just leave this G factor with this 1.0. And then in this case, I will save this slope with as a file on this lab3 folder. So I just use named slope. So save, and then click run. So close. Then you can find this slope image from the DM data. Okay. After that, I will calculate this aspect from the raster terrain analysis as well. So click and double click. After that, you need to select this SLTM DM data first, and then click to save this file with the aspect. And then just save. After that, click run. Okay, so close. And then you can find this aspect processed data with the DM data. Okay. So based on this aspect raster data, I will select the portion of this aspect data with some the conditions. In that case, I will use the raster calculator. So there are three ways to access the raster calculator. The firstly, you can select the GDAR tool, and then raster miscellaneous toolbox. You can find this raster calculator. Okay, and then the second way to click this saga tool box, and then you can select expand this raster calculus tool box, and then you can find this raster calculator. But in this case, I will just use this raster analysis toolbox to select the raster calculator on here. So double click. After that, you can select some expression. You can make the expression with the selection of the layers with this aspect. As I told you, I will make the selection with some portion of the aspect data. Okay, so with that, I will select less than 90 degree, or again select this aspect greater than 270 degrees. Okay, so in this raster calculator, there is required to select this reference layer. Okay, so in this case, just open this multiple selection and then just select this aspect as a reference layer. So click OK. And then lastly, I will save this processed output data as a file. So in this case, I will save with this the processed data with aspect and wall nodes. So just click save, and then I'm ready to run this the last calculator. So press this run button. Then you can find this the collected and selected some portions from the previous aspect with the considering the nose part. Okay, so you can find this aspect nose the layer newly added on this the QGIS panel. Okay, so as you can see on here, the value of this aspect nose would be 0 or 1. This would be just selection of the false or true. Okay, so now I will do another processing with the Rust calculator. In this case, I will just consider this slope case. Okay, so firstly double click this slope, and then less than equal to 2 degree. Less than equal to 2 degree. So on here, and then also you need to select reference data. In that case, I will select this slope. Then click OK, and then how about save with this the slope? Oops. With this button, then you can name with a slope LTE2.TIF. So you can just leave without TIF, but if you want it to image file, you can insert. You can type .TIF file. Okay. So in this case, I will just make as a TIF file. So just save and then run. So after that, you can find this newly created slope data. Okay, so how about another one for the slope? Just this one, and in this case, less than or equal 5 degrees. So it is the same with the reference data with the slope, and then save with output as a slope LTE5. Okay, so click run, and then you can find more different slope data, slope raster data, less than equal to 5 degree. Okay, so you can do this kind of processing with this Raster calculator. Okay, so now I will combine all the processed Raster analysis result with this Raster calculator again. So in this case, firstly I will select this aspect north first, and then just equal 1 and A and D, and slope less than 5 degree, less than or equal 5 degree would be 1. Okay, this is just true. Okay, true case, and then make this the combined one. After that, another expression or, so or, and then slope less than 2 degree equal just true. Okay, so in this case, I will just use this reference data with this aspect as well as slope. So click OK. Then need to save this process the output with the TIF file, so I will name it all conditions.tif. So save and click run. Then you can find this all combined conditions, the raster data. Okay, so this would be combined with this slope 5 degree considered and 2 degree considered and this aspect north. So from this aspect and slope data, so we can create this all conditional things. So based on that, now I will simplify the rest data, this all conditions with the GDAL tool. So just collapse this one and then just expand this GDAL tool and then click this raster analysis tool. After that you can find this sieve tool, so double click, and on here you can find the input layer with all conditions, and then how about threshold for that sieve things with the 8. So this 8 threshold means minimum 8 contiguous pixels with that this all conditions. Okay. After that, just check this use 8 connectedness. Okay. And then you need to save this file as this all conditions with another underbar sieved. SIEVE. Just save .tif file and then click run. So after some seconds you can find this processed the data on here. So all conditions save data on here you can find. So actually this all conditions save data means very tiny areas from these all conditions are need to exclude as the useful data. So we just selected very tiny areas from the previous all conditions. So you can find on here the value of this raster. So you can find this information. On here you can find very tiny the areas, very tiny things with minimums exist. We need to exclude all these ones. So just cancel, and in this case I will use again this raster analysis with the raster calculator. So on here for expression I will select this all conditions sieve data. After that just this would be excluded, so less than equal if this one with the 0 and then just make as 0. Okay, so on here I will select this one as a reference data. After that need to save TIF file with the output name. So in this case I will just make this save to condition simple SIMPLE. So click save and just run. So after that you can find so now you can find the newly created this simple all conditions one. Okay, so at this point you need to save this project with this save project button. After that I will make demonstrations for reclassifying the raster data. So in this case just find on this raster analysis you can find reclassify by table. So double click, and then firstly I will use this aspect for this the reclassify thing, and then open this reclassification table, And then you can make this table. In this case, I will make 5 rows first, and then I will type the numbers on here. Minimum 0, 45 with value 1. So value 1, this one would be 315, 360, and 45 with value 2, value 3 and 4, and then 135, 25, 5. Actually, all these numbers means represent the aspect with the direction. So this value 1 with these minimum and maximum values means the north direction things, and then the second one would be east direction, and then south and west direction. Okay, so I just created this table for the reclassification. Okay, just click OK. And then now you need to check all the parameter required, but in this case I just save this file with the TIF file named reclassify. Okay, so just save, and then you need to click this run button. So after that, you can find this reclassified one. So please move on the top. So this would be nearly created the reclassified data. So on here, you need to right click to open this property for this layer. And then on here, for the Symbology tab, you need to select this paletted and unique values first, and then this band gray. After that, how about the random colors for the color lamp, and just press this classify button. So you can find this suggested colors for that. And then how about click this apply button. Then you can find this the reclassified the aspect data with the different colors. Okay. So for this, you may have the different aspect colors because we just selected the random colors for that. Okay. So the last demonstration for the raster data analysis would be calling all the values with this analysis to the raster data. So on here, the menu, you can find this identify features the icon. So click with that. You can select any positions for these rasters. So I will select on here, and then you can find a new window for identify results. So actually, on here you can find the reclassified values for this reclassified layers would be just 1 with this green layer, green colors, and all the different layers you can find, but in this case I will expand on here for this SLTM DM data. On this position, the elevation would be 7 to 8. So I mean, on this SLTM data on here would be the value for the elevation would be this amount. Okay, so you can also identify another position, but in this case you should open these the values except for these top values, so you can see. So if you close this one and then open these plugins with this manage install plugins, after that I will search the value tool. So VALUE tool. Actually I already installed this one. So after that you need to check this value tool, and then you can find this value tool on here. So if you click this one and then it duct on here, so you can find all the values associated with these layers. So in this case, more convenient to find the values. If I go over there, all the locations, it automatically represent all the data associated on these values. So you can find all the different values on here for all the layers. Okay, so you can identify all the rest values with this identify feature icon as well as this value tool. Okay, so in this video you have seen how to drive all kinds of analysis products from our DEM data. These include hillshade, slope, and aspect calculations. You have also seen how to use the raster calculator to further analysis and combine these results. Finally, you learned how to reclassify a layer and how to query the results. Now you have completed two analyses from the previous videos. The vector analysis, which shows you the potentially suitable plots, and the raster analysis that shows you the potentially suitable terrain. Based on that, I will continue the work required to run about QGIS desktop for QGIS training manual with the next modules in the coming videos. Thank you for watching.